On the streets, my brother's dying, and I hear the mothers crying, crying out, and the way that things are.
There's one serious consideration, and that's that on the GMO process, as well as on glyphosate, I don't know of a single scientifically peer-reviewed study that shows that they're safe. Either one. It's been assumed that that's the case, but I haven't seen any of the scientific papers published or submitted to the EPA that declare or would establish the safety of either product. When we went to the GMOs, we have a 15-fold increase in the exposure then to glyphosate, because 85% of our commercial crops are glyphosate resistant, Roundup Ready. Glyphosate has been a very powerful tool for us in agriculture for weed control. The reason for that is that it's systemic in the plant, it goes throughout the plant. You squirt it on it, and then it will distribute throughout the plant. But it accumulates in the shoot, root, and reproductive tissues, and the meristematic tissues. It can have a very long half-life in a clay-loam soil. A half-life has been recorded to be as long as 22 to 23 years. In a sandy soil, it's a little shorter than that. But as it's in the plant, 80% will stay in the plant for the life of the plant or until it's fully degraded. 15 to 20% moves down into the root system, and that's where it shuts down the plant's defense mechanism against your soil-borne pathogens. So that the mode of action of glyphosate is to essentially give that plant a bad case of AIDS, so that the soil-borne organisms then, once the defense mechanism is shut down, it's the soil-borne organisms that do the herbicidal control. As it moves out of the root system, it stimulates the soil-borne pathogens and increases their virulence. Glyphosate actually downregulates 291 enzymes. It upregulates 30. Among those 30 are the virulence mechanisms for Fusarium, Phytophthora, Pythium, Gomonomyces, and a number of other soil-borne pathogens that then become very active, even more active than we see normally against the crop because of their residual activity. It reduces the nutrient uptake from the soil, and it's shutting down many of those critical enzymes that are required for efficiency of nutrient uptake. It's a patented, very powerful antibiotic against the beneficial organisms that we rely on, both for defense against our soil-borne pathogens, as well as for nutrient uptake and availability. So that even though it's been a very powerful chemical for us to use for weed control, until we have the resistant weeds now that have nullified much of that, it has some very serious consequences as far as the unintended effects of this very simple, systemic chemical that we indiscriminately apply throughout the environment. We change the soil biology. It's active at very low rates. 12 parts per billion, or about 11 grams per acre, will inhibit the uptake of iron, manganese, and zinc 90 to 95% as far as its translocation then throughout the meet the plant's physiological needs. Some research we did with sugarcane. We were concerned about the high incidence of end-stage kidney failure with our sugarcane workers. Consulted in Brazil and Central America and a number of other countries for years. I'm very concerned about the end-stage kidney failure from the exposure to the glyphosate. It's anticipated that 1 in 4 sugarcane workers will die from end-stage kidney failure at a very young age. We did this research to show how quickly glyphosate is systemically moved through the soil, or through the plant. And you can see that within 6 hours after application of the glyphosate, you have more than 100 times the amount of glyphosate in the plant than is required to inhibit all of the cations, the non-bound cations in that plant. You can see that effect on manganese and iron. It's about a 30% reduction in zinc movement. If you don't have zinc, no, that's just a 30% reduction. You don't have membrane permeability in the cells. You don't have manganese, greatly restrict your photosynthesis. But it's a very unique chemical in that it's a very powerful chelator for the cation mineral elements, very powerful antibiotic, and of course a very powerful broad-spectrum herbicide. Again, it can be residual in the soil and it builds up. I've seen soil samples in Australia, the US, Brazil, Central America, where we can account for 100% of the glyphosate that's been applied either as glyphosate or as AMPA, the first degradation product, for the last 20 years. Essentially, the only degradation has been moving it over to the AMPA, 1-decarboxylation, which is 1.5 times more toxic than the glyphosate would be itself. So that many of our farmers will say, well, my crop isn't as vigorous as it used to be. It's not as active. It's not doing as well. And they'll ask an agronomist, and he'll tell them, well, the soil's cold or the soil's wet, too much residue on the soil, and you see all of the nutrient deficiency symptoms, and sure, those systems can reduce nutrient uptake. They don't think of the residual glyphosate that's being accumulated in that soil from 35 years of very heavy application. So we've changed the system. Again, it's a very powerful antibiotic that can break down the other organic phosphates. There are very few that can degrade glyphosate in most of our agricultural soils. So that we see an increase, and this is even in the Roundup Ready soybeans, because there's nothing in the genetically engineered plants or tolerance to glyphosate does anything to the glyphosate. It's still there as a very powerful mineral chelator to immobilize those minerals, and a very powerful antibiotic against the organisms that fix nitrogen or mycorrhizal organisms. In 2 weeks after applying glyphosate as a ripening agent or a desiccant on sugarcane, we've completely lost all of our mycorrhizae there that are very critical for the next ratoon crop. You can see those organisms that would be responsible for controlling our soil-borne pathogens are very sensitive to glyphosate. Our nutrient reducers for iron and manganese are also very sensitive to glyphosate antibiotic activity and the other organisms there. It has a great impact on the environment. I was at Utah about 2 weeks ago at a farmers meeting. They said in the entire valley they had 100% loss of their bees. High glyphosate utilizing the area for their foreign production, had colony collapse disorders. So they can't understand why. Well, bees have a requirement for 2 bacteria in the stomach, the honey crop, in order to digest the honey and the bee bread, the protein. Glyphosate is very toxic to those 2 organisms, Lactobacillus and Bifidobacterium. So that when you take those 2 organisms out, you not only affect the digestion of the food for the bee, but you also remove its immunity from foul brood or varroa mite or any of the virus diseases, so that the bees die out very easily then. Glyphosate's also an endocrine hormone disruptor, so that the bees never really learn how to forage efficiently. They're foraging on a lot of Roundup-ready crops, so that the nutrient density in those crops and in that pollen that they're collecting is greatly reduced. They're dying also because they're malnourished as far as the micronutrients go. You see this research of Amos compared bees that were foraging on the GMO versus the non-GMO, and you can see that on the non-GMO, if you look at the honey crop, it's just a very viscous liquid. It's being digested and being utilized then by the bee to keep the tissues nourished and healthy. But those bees that were foraging on the GMO crop with the glyphosate couldn't digest that material. It appeared just as a bunch of gravel in the honey crop, rather than being digested and utilized as a nutrient resource. And so the tissues eventually died then from starvation of those nutrients. We've had such a tremendous loss of bees throughout the country that we're actually shipping bees from one side of the continent to the other just for almond pollination, for apple pollination, and other processes. And so we have several of our bee apiaries that have developed their own remediation for this, and they do it with a probiotics mixture and water of the lactobacillus and the bifidobacteria with a few minerals. The minerals in it are to detoxify the glyphosate that they're picking up from the environment or from the water, and then they add a little honey or sugar. They can go from 40 or 50% or even 100% loss down to less than half to 1% loss of their bees with this probiotic mix just in the water for the bees to forage on. So they recognize the seriousness of the problem. We have other environmental impacts. University of Wisconsin researchers reported this last winter that 1/3 of a pound of phosphorus going into Lake Erie is from each acre of the watershed. And it's going in not just as phosphorus, but as glyphosate. Well, glyphosate is usually detoxified as an herbicide by very rapid chelation with the minerals in the soil, your calcium, magnesium, and iron, other materials. What it tells you is that we have saturated all of the area around the entire watershed of Lake Erie in North America, to the point now that this highly water-soluble glyphosate is moving into the water. The algae are resistant, naturally resistant to glyphosate, and so we have the algal blooms and the eutrophication, not from the phosphorus in your laundry detergent, but from the phosphite of glyphosate. Again, the The mode of action as an herbicide of glyphosate is increased pathogen susceptibility. You can't kill a plant with glyphosate in sterile soil. It stunts it, the growth regulator, but it shuts down the defense mechanism so that in sterile soil, in 2 or 3 weeks, when that plant recovers the micronutrients that have been chelated by this strong chelating agent, all of those lateral buds will break, and you'll have a tremendous bush that will develop over here. In field soil, where you have the natural pathogens present, you see that it's just a matter of that 4 or 5 days or 6 days before that plant is colonized and the pathogens have performed their herbicidal activity on it. This research first developed, or the first published report that I'm aware of was 1984, Rahe and Yohal. It's been repeated many times. I've had weak scientists that have challenged me a number of times on this, and I tell them, set up the experiment. It doesn't take much to have an autoclave bucket of soil and non-autoclave bucket, and you spray your plants, you'll see exactly the same thing. The latest report that I'm aware of was Jessica Shepard's PhD thesis at Purdue University, showing the same thing with 5 weeds that are resistant to glyphosate, showing that the resistance isn't to the chemical, but the resistance is to the soil-borne pathogens. Fusarium, Rhizoctonia, Phytophthora, Pythium, Cornospora, and all of the other organisms there. But as a consequence of that, we have over 40 diseases, plant diseases, that now we consider on our threat pathogens committee that I've served on for over 40 years, that we refer to as re-emerging diseases because our control measures for these diseases aren't as effective, and these diseases are continuing to develop to threaten the sustainability of our crop production. We also see some new diseases developing, like Cornospora, root rot on soybeans, and you see that pathogen, or that soil-borne fungus that we used to consider just a root nibbler, now can become a very serious pathogen. In Brazil, it's the number 2 soybean pathogen, second only to rust. I've seen up to 40% loss in soybeans in the Midwestern United States from this organism that we used to consider just a soil saprophyte. But as you can see what happens when you add a little bit of glyphosate to the leaves of these Roundup Ready soybean plants, and look at the damage to that root system. We have many areas of the world where Xylella, scorch or wilt type disease organism, is becoming epidemic. We're about to lose olive production in Italy and Spain because of this disease. We have citrus variegated chlorosis in Brazil that almost wiped out the orange production there. The same thing in that citrus plant or olive plant or coffee or other plants infected with Xylella occurs there when glyphosate is used as a ground cover or for weed control of their ground cover weeds. The biofilm that bacterium produces is actually calcium manganese phosphate, fernosite. We see it outside the plant as the black layer here. You see it with the take-all fungus. This is what area running right adjacent or right underneath the fungus as it's oxidizing manganese and those tissues to a non-available form be then that shuts down the shikimate pathway and the other defense mechanisms that require manganese as a nutrient source, and the pathogen then has no resistance to its colonization. In this situation, the organism wasn't considered a pathogen, and it doesn't do any significant disease usually without the presence of the glyphosate as it comes down and is exuded from the root exudates. We see a situation, this research field at Drew University. It's been in the same crop rotation, the same tillage practices. It's a large field for the past 30 years. A few years ago, we had a situation where this half of the field developed a very severe root and crown rot that we refer to as take-all disease, soil-borne fungus. This side of the field just had that fungus with localized lesions and a little bit of root nibbling. Everybody was trying to figure out, well, what happened in the middle of this field that they've never seen a separation like that before for 30 years, and the field's been in the same tillage and same weed control, same program every year for 30 years. What divided it in the middle? It's not where the drill went. You see here the clear demarcation between very severe disease, where if you roll out the years, all you have on this side is shriveled grain. Over here you have still very plump kernels. The difference was that the previous crop was Roundup Ready soybeans, and it had one application of glyphosate on this side of the field more than it had over here. It had two applications here because the farm superintendent said there are two late emerging weeds that are coming in over there. Sent his crew out, put a red flag down there and told them you spray to the flag. We don't have any problem over here, but this is a showcase for our farmers, so we have to have it completely clean. One application of glyphosate on the previous crop changed the soil biology so that we see a very significant increase in severity of that disease. Fusarium head blight, Fusarium graminearum, and other Fusarium species also shows a similar association, so that we not only have the root rot phase of the disease, but we also have the head blight phase, and also the mycotoxins are increased proportionately. Andreas Tiedemann of our National Fusarium Head Blight Forum shared his research 3 years ago, showing that it's not safe to even use the straw as bedding in the cattle, and for cattle or for pigs, because the pathogen now is producing the toxins, the zatarone and deoxynivalenol, in the root system, and it's translocated up to the head. But the kernels look plump rather than light and ghosty, so that we can't just turn up the fan on the combine and blow our profit out the back and say, well, we really reduced the toxin level, because the toxin level doesn't show as that shriveled grain because it's coming from the root system up. So that many of the animals that are on that were chosen as a bedding, actually will have high enough levels that they'll be infertile from the estrogenic toxin, the zatarone toxin there. Dr. Miriam Fernandez of Saskatoon showed that if you have used glyphosate as a burn down before your wheat or barley one time, in the previous 3 years you'll have a significant increase in head blight. You use it every year as a burn down, you'll see about a 300% increase in severity of this disease and toxin levels than in the grain. As a very powerful antibiotic, it changes the gut microbiome for those organisms that we rely on for our mental health, for our nutrient absorption, and also for our immunity. So that it's a very powerful chemical, not just from immobilizing nutrients, but also as an antibiotic for our gastrointestinal conditions. Monsanto went to EPA and said mammals don't have the EPSPS enzyme or the shikimate pathway, so that it will never be toxic to mammals. But our GI tract has many of those organisms that do have the shikimate pathway that we rely on for our immunity and mental health and nutritional support through the aromatic amino acids. And so we see that situation, there's some research of Claire and others here, showing that it's toxic as an antibiotic against your microbiome. This is poultry microbiome here. And these would be those organisms that are very beneficial, that are very sensitive to glyphosate. These are your pathogens which are insensitive or oftentimes even stimulating. Dr. Monica Kruger, in investigating an outbreak or a major incidence of chronic botulism, showed that at glyphosate levels less than 1/10 of a part per million in the feed will completely wipe out your beneficial organisms that suppress your Clostridium botulinum and also prevent the production of the neurotoxins, very powerful biowarfare agent there. And at 1/10 of a part per million, it wipes your beneficial organisms out. Clostridium develops, and it's just a matter of time then before the cattle or the pigs or poultry will die from chronic botulism. It's a condition that many of our veterinarians still don't recognize. They recognize acute botulism, but they aren't familiar with the chronic botulism that gradually builds up that neurotoxin for such damage. There's some recent data. Dr. Ted Duke-Meyer, a regional veterinarian in Canada, gets about 30 cases a month, almost one a day, of chronic botulism now in their animal production. These are just 3 of them, 130 beef calves, used desiccated lentil and flax straw as bedding for the cattle for the 800-pound calves. Lost 29 of them in one day. And the loss of stock when you get rid of the glyphosate. It takes 3 or 4 days lag period, and sometimes 2 or 3 weeks before you get full recovery. You can see with the 300 cow dairy, 1 to 2 dead each week. Not going to stay in business very long. You've got chronic botulism. Poultry, 25 to 30 per day, and you can look at the levels here. Even this 0.5 parts per million level up here is over 4,000 times lower than the EPA says is perfectly safe to have in some of our water and food products. Yet you can see what it does as far as the gut dysbiosis in those conditions. We look at the incidence of disease, and you see that 35 to 36 of these diseases have the same epidemiological plot, epidemiological curve. Served for 8 years on the Surgeon General's Global Epidemiology and quadripartite epidemiology committees, where we investigated this type of phenomena. You see that identical or essentially identical curve with all of those diseases. This is CDC's data, Center for Disease Control, along with the USDA data for glyphosate and GMOs, and you see that same curve, epidemiological curve for every one of these diseases. You can't find any other condition other than the glyphosate and the GMOs that will fit that epidemiological data. There are other conditions that will increase each of those diseases. Aluminum, for instance, with autism. Or you'll have glyphosate in many of our vaccines. You'll see that same relationship. But all of these fit the same curve. Not that correlation is causation, it isn't. But when you get all of these curves pretty much identical at Pearson's correlation coefficient of 0.9 to 0.999, then somebody should be looking at it. Somebody should say, is it causation or correlation? That was our responsibility for the Surgeon General, to set up those scientific panels. And I've had that opportunity to do that for a number of diseases. No one wants to even touch it if they think that GMOs or glyphosate are involved, because it's poison as far as your professional advancement and career. And so we take the losses. But you also have to remember that medical data is 8 to 10 years delayed in getting plotted out. So that even if we stop today, those curves will continue for some time. And you see the effect also as an endocrine hormone disruptor, not just in animals and our wildlife. You see, I don't know how that chick with the perforated beak and everything made it out of the egg. It's a common phenomenon in our deer and elk. In fact, we had entire herds of deer and elk this year. This spring, still running with a buck because none of them conceived last fall. The infertility levels were unbelievable. And then you see cleft palate, as Tyron Hynes has shown, also with the endocrine hormone disruptor and with atrazine and the other endocrine hormone disrupting chemicals. And then you have the tragedy at Yakima, Washington, Yakima County, Benton County, and Hamilton County, where in 2008 they had the invasive weeds in the three rivers that go through those three counties, and they said we have to get rid of them, and the EPA said perfectly safe to have 700 parts per billion glyphosate in the water. Those three rivers provide the irrigation, provide the drinking water for everyone in those counties. You see, within 2 years, we had an 8,000% increase in a major epidemic, where if you got to hold your baby, it was just for 24 or 48 hours. So we only have 2 years data because everybody, all the medical personnel were told this isn't a reportable situation, and anyone that reports it will lose their license because of violation of the federal privacy laws. But you see that impact here. Tremendous damage. You see the inflammatory bowel diseases. And I could tell you a lot of situations there. This is some data that came out just recently in the cancer trials in California. It's Dr. Anthony Samsel has published it. He can't publish the full study that Monsanto conducted in 1981. This is Monsanto data. You see when they set it up, it's a 2-year rat study. Dr. Seralini and his study at the University of Caen in France essentially duplicated this study. Monsanto had already done it in 1981. 23% of the animals on receiving glyphosate in the ration developed malignant lymphomas. 0 in the controls. Again, I consult on sugar cane and bananas and coffee and other crops. Central America and other areas were concerned about the end-stage kidney failure. In order to, all of our growers and the Sugar Cane Foundation in Guatemala said, we can't produce sugar cane without glyphosate as a ripener. We get another 2.5–3% sugar if we do it. A group of us sat down and said our purpose in growing sugar cane isn't to kill it, but to capture the sun's energy and to store it as sugar, and then with a little bit of nitrogen we have the protein as a food source for us. Said, why don't we emphasize growing sugar cane and producing sugar rather than trying to kill it and terminate it? We developed a very simple nutrient approach. We use a kilogram of boron can't think of it's actually 200 milligram of boron, actual boron, 200 milligram of molybdenum, and 200 milligram of manganese. The boron's there to move the sugar into the storage, make sure we get it there. We spray this nutrient mix on 4 or 5 weeks before harvest, just like they would the glyphosate. The manganese is there to really perk up photosynthesis to produce the sugar, and the molybdenum is there to utilize the nitrate nitrogen that would interfere with sugar extraction. This year, this is the second full year that the entire mill has been on it, 64,000 hectare with check strips. And every one of the 200 farms that are on that, our production was increased 31,000 tons. More sugar, refined sugar produced with the nutrient compared with the glyphosate at 28% less operating costs. You see that effect carrying through every year. Last year, their profit margin with our nutrient approach versus the glyphosate was $3.5 million. It'll be more than that this year, and it'll be more than that next year. We can get them back out to that 8 or 9 ratoon crops rather than 2 or 3 ratoon crops before they have to plant. So that you see those results, and you see that effect there. There are other alternatives. You see the effect on our children. We've sacrificed an entire generation. In 2007, it was 1 in 150 kids. 2 years later, it was 1 in 100. You see, a few years later, it was 1 in 50 or 1 in 38 now of our children that have autism spectrum disease disorder, and it's anticipated to be 1 in 2 in just 5 years, 6 years. In 1970, before glyphosate was released, it was 1 in 10,000. Well, the solution is, when you find yourself in a hole, quit digging. So I'll just throw out those 5 R's for restitution or for problem solving. We need the education, we need labeling, we need to restrict the damage, and there are several products that are now available that do remove the glyphosate from the body. It doesn't remove it from the brain. From Monsanto's own label studies, glyphosate accumulates in the brain, the bone marrow, all of your organs, and all of your muscle tissue. It's a systemic chemical that accumulates in the body. So with the humic acid and folic acid combination, or with the clinoptilolite, the zeolite form, you can remove that glyphosate. It takes anywhere from 2 to 3 weeks for a human. On a cow, it may take 5 or 6 months to restore fertility and also to fully remove the glyphosate glyphosate to a non-detectable level in urine or blood. So that there are some things that will work. Dana Stanley at Central Queensland University has shown that with the clinoptilolite, that it will also remove your pathogenic Clostridia and Salmonella and E. coli pathogens from poultry, so that Australia was able to renew its exports of poultry products to the Asian countries by demonstrating that just a pound or pound and a half per ton of feed of the zeolite farm here would do it. We see the same benefits then of approaching many of our other diseases, sudden death syndrome on soybeans. We see the similarity to magnesium deficiency. XP Yang showed this year at Iowa State University that a simple seed treatment with magnesium and manganese will eliminate this disease. Involved in mineral nutrition. Yoshi Yamada got us all together in Piracicaba, Brazil. We worked on it on this disease, different approaches. First thing you notice with CBC, with that plugging of the xylem, is that your zinc and manganese levels bottom out. Because the xylem, your plumbing is all plugged. So we worked at different ways, hoping that we could maybe keep glyphosate in as a weed control to give the growers an opportunity to phase out. We couldn't find any system that would counter that very powerful mineral chelating and antibiotic activity of the glyphosate long enough to maintain this disease, so we went with brachiaria grass and went as a mulch. We mulched between the rows. Brachiaria grass has some unique characteristics. It inhibits nitrification so that the tree is primarily under an ammoniacal source of nitrogen rather than nitrate. All of the nitrogen and nutrients come from mineralization of the grass. Best weed control you can get is darkness. We mulch twice a year, mulch it. In 1 year, we had the manganese and zinc levels and other nutrient levels restored in the tree. In 3 years, we were producing 110% more of the fruit than they did before introduction of the disease. There are alternatives, there are other ways to do these things if we're willing to look at them. Just to give you some examples. Mineral chelating stability. I appreciate the opportunity of sharing here with you. Again, glyphosate is a very simple chemical. It's a synthetic amino acid for glycine. Our simplest amino acid. You can't see it, taste it, or smell it, but again, it can slowly kill you. Again, many thanks for the opportunity and appreciate your patience here with me. I'm a little over time. So, Daniel, thank you.
You're